All right, this note card is number 88. Title is Area of Regular Polygons. Area of regular polygons. So on Friday we learned what a regular polygon is. What is a regular polygon? For a regular polygon, are the sides different lengths? Yes.
No.
Correct, they are not different lengths. All the sides are the same length on a regular polygon. What else is true on a regular polygon? All the sides are the same length and...
All the angles are the same?
Good, all the angles are the same. So a regular polygon is a polygon where all the sides are the same length and all the angles are the same measure. So new vocabulary word is the word apothem. I'm not saying opossum. That's a small, ugly animal. This is an apothem. An apothem is a line segment drawn from the center of a regular polygon that is perpendicular to one of the sides. A line segment drawn from the center of a regular polygon that is perpendicular to one of the sides. So I'm going to draw a regular polygon. At least I'm going to try to make all the sides look the same length. That's not terrible. All the sides are supposed to be the same length. This is a regular octagon. And all the angles are the same as well. Okay, so the apothem goes from the center and it's perpendicular to one of the sides. So maybe this way. That line segment, that's called the apothem. Now, it's easy to get it mixed up with a different line segment. Sometimes you draw a line segment to the corner. That's not the apothem. If it goes from the center to the vertex, it's not the apothem. But if it goes from the center and it's got to be perpendicular to the side, that's called the apothem. All right, so the reason I bring this up is you need the apothem to find the area of the regular polygon. So here's the formula for the area. The area is 1/2 times P times A. So this is the area formula for a regular polygon. So what do you think the A stands for? Apothem, good. So of course, that's why I brought it up. I needed to tell you what the apothem was so that you could use this area formula. And then what do you think the P stands for?
Polygon.
Good guess. That's not it. Yeah. It actually stands for the perimeter of the, so that's the distance around the regular polygon. So to figure out the area of this octagon, you find the perimeter, so add up all the outsides, and then take 1/2 times that number times the apothem. And then that'll give you the area. All right, that's it for the note card. Here's a hole punch for you. The title of the paper is also Area of Regular Polygon. We're going to start with number 6. So here's the picture on number 6. And you can't tell for sure just by looking at the picture, but the directions say that the polygon is regular. So that means all the sides are equal and all the angles are equal. And then it says, okay, so since we have a regular polygon, please find the area of this. Well, the directions don't say please, but I'm saying please. So find the area of this is what we're trying to figure out. So since it's a regular polygon, we can use this new formula that we learned. This is the formula just for the area of regular polygons. But before we can use this formula, we need to figure out the perimeter. So that's what we're going to start out with. So how do you find the perimeter? Yeah, Maddie. Just add up all the sides, right? And they only gave us one of the sides. But it's a regular polygon, so they're all the same. So even though they didn't mark this as 2, they said it was a regular polygon, so we know it's 2. And this is 2, and that's 2, and that's 2. So you just add up 2 plus 2 plus 2. There's 6 of them added together, right? I forgot to label that. It's 12 centimeters. So that means if you walked around the outer edge of the polygon, the distance is 12 centimeters. It counts how many lines would fit, right? 1, 2, 3, 4, 5, 6, etc. That's what perimeter is, the distance around. It's how many lines there are, how many centimeters. But that's not what the question's asking. The question's asking for the area. So we're going to take 1/2 times that perimeter. So I'm just using this formula, times the apothem. And if you look, you can see the apothem is square root of 3. You do have to be careful. Sometimes the problem gives you this line instead. That's not an apothem, because this is going to the vertex. To be the apothem, it's got to go and make a 90 with the side. But this time they gave it to us, so that's why it's square root of 3. All right, now returning to this, we have 3 numbers multiplied in a row. And if you have 3 numbers multiplied in a row, you can multiply them in any order you like. So we're going to take 1/2 times 12 first. That gives us 6. And then it still says take 6 times the square root of 3. Now we could go ahead and do that. We could take 6 times the square root of 3. The problem is, the square root of 3 is a huge, nasty decimal. So if we took 6 times that, we'd get another huge, nasty decimal. And I'd rather not deal with that. So we're just going to leave it like this. It seems like it's not an answer, but it is. It's the exact answer. So what would the label be for this?
What did we say?
Yeah, good, because area is counting how many squares there are. There's 1, 2, didn't draw that square very well. Counts how many squares would fit on this regular polygon. So it's the squares. All right, now back to number 5. Here's the figure on number 5. Directions still say find the area. And this problem is so much fun, I'm going to do it twice. So this is a regular polygon. That the directions say that polygons are regular. So if this is a regular polygon, what's another name for it? It's a 4-sided figure with 4 equal sides and 4 equal angles. So that's called a square, right? If all the sides are 4, that makes it a rhombus. But then if all the angles are 90, which they are because it's regular, then that makes it a square. So this is a square. So that means it's also a parallelogram, because this side's parallel to that side, and that side's parallel to that side. So we can use the area formula for a parallelogram. Now, it's been a while since we wrote that down, but it's not a tough one. Area for a parallelogram is just base times height. So that's on your math reference sheet for the air test that I gave you, or it's on a note card. Area for a parallelogram. So the base is 4, and the height is 4. So area is just 4 times 4, which of course comes out to 16. So this is the way I would expect you to do the problem if you were doing it by yourself, because this is the simplest way. Recognize that it's a parallelogram and just take base times height. But since we have a new formula today, I want to show you that that formula could work also. So since this is a regular polygon, we could use the 1/2 PA formula to find the area. So I'll start off with the perimeter. And the perimeter is just 4 plus 4 plus 4 plus 4. That comes out to 16 inches. It's a total coincidence that the area and the perimeter are the same number. That's not usually the case. So don't start thinking, oh, I'll just do perimeter and area, and it's the same thing. It's not. Perimeter is counting how many lines there are on the outside. Area is counting how many squares there are fitting inside, right? And this particular problem happens to be the same number, but that's totally a coincidence. All right, so here's our perimeter. So now for our area formula, we take 1/2 times the perimeter times the apothem. And they labeled the apothem. It's 2. So you just take 1/2 times 16 times 2. And of course that comes out to 16. We already knew the answer for the area was 16, right? So it's a good thing I got the same answer again. Otherwise I would have looked kind of bad. Nobody notices. If I do the problem once, usually people don't notice if I miss it. But if I do it twice and get different answers, people would know. So this is the right answer for the area. We just got it 2 different ways. Using the new formula, 1/2 times PA, or using the old formula, just base times height. So what's a regular polygon again? All the sides are equal, and also all the angles are equal. Good. And this new formula today is just a formula for finding the area of those polygons.